Lesson 2, topic, rational and irrational numbers. Learning target, I can identify rational and irrational numbers. Vocab, rational numbers are numbers that can be written as a ratio of two integers. So we talked about rational numbers in our vocab with our Freyer model, and we had integers are rational, because we can write 6 as 6 over 1. Fractions are rational. And those ending and repeating decimals. So if they end or they repeat, then they are rational numbers. Irrational numbers are numbers that cannot be written as a ratio of two integers. So, reminder, our most popular irrational number is pi, and then those never-ending, non-repeating decimals that go on and on without a pattern. Perfect squares are the results when we multiply two integers together. So 2 times 2, the same number, 4, and that makes a perfect square. 2 squares by 2 squares. 3 times 3 is 9, so 9 is a perfect square, and we have 3 squares by 3 squares. 16 is a perfect square, and 25 is a perfect square, and that keeps going on and on. We can do 6 times 6, 7 times 7, we could do 100 times 100. And that would give us a perfect square. So then when we take square roots of perfect squares, we get nice, pretty whole numbers. The square root of 1 is 1 because 1 times 1 is 1. The square root of 4 is 2 because 2 times 2 is 4. The square root of 9 is 3 because 3 times 3 is 9. The square root of 16 is 4 because 4 times 4 is 16. And we can fill out the rest of our table. Just like that. So the square roots of perfect squares are going to be rational numbers. But all the square roots in between are not rational, they're irrational. So like the square root of 74, it's between 64 and 81, that's going to be irrational. It's not going to come out to a nice whole number. So let's practice classifying numbers as rational or irrational. We'll start with -5. -5 is an integer, so it's going to be rational. We can write -5 as a fraction, as that ratio of two integers, -5 over 1. The opposite of the square root of 81. Now, if you remember from your chart that we just filled out, the square root of 81 is 9, because 9 times 9 is 81. So the square root of 81 would be 9, so this would be -9, and -9 is rational. So we can put the opposite of the square root of 81 in the rational column. Next, we have the square root of 47. The square root of 47 is not on our chart. It's not a perfect square. We don't have two numbers that multiply to make 47 that are the same. So that is going to be irrational. You can also check your square roots in your calculator. So if we do the square root of 47, you see we get this long decimal that goes on and on, no pattern, no repeating. So that's also another way to know if square roots are rational or irrational. Next, we have the fraction 4/3. Fractions are already written as a ratio of two integers, therefore fractions are always rational. Next, we have 9.2. 9.2 is an ending decimal, meaning it goes in the irrational column. It ends. We can make sense of it. We can write it as a fraction, a ratio. I would like you to try the next 3 numbers on your own, enter them in Edpuzzle, and see if you are right or wrong, and then you can move on to your practice.